Hello everybody, my name is Srijon Chatterjee. I welcome you all to our YouTube page of Ramakrishna Mission ITI. Today we are going to discuss a topic which is related on the law of thermodynamics, which is a very important topic related to our refrigeration and air conditioning trade. So first of all we have to learn that what is the word thermodynamics, what does this word means. If you break down this word thermodynamics, you will get two smaller words, that is thermo and dynamics. Okay. From where does this thermo came? Thermo generally comes from the thermal, the word thermal. Now what does this word thermal means? Thermal means heat. Okay. And what is dynamics? Dynamics means a state of motion. Okay. So what does the word thermodynamics give us the meaning? The word thermodynamics give us the meaning that the heat in the state of motion. So thermo comes from thermal, which is the meaning of thermal is heat, and dynamics came from the dynamics means the state of motion. So the word thermodynamics means the heat in a state of motion. So during this process, during the movement of the heat, there are generally three laws that we have to learn most importantly, and the laws that we are going to discuss, I have written it here already. Okay. So first of all I will give you the first law, which is known as the Zeroth Law of Thermodynamics. So what does this Zeroth Law of Thermodynamics states? Zeroth Law of Thermodynamics states that if there are three bodies, okay, if there are three bodies, let us assume that the bodies be A, B and C, and their temperatures are equilibrium, means their temperatures are equal to each other. Means what I am trying to say, that suppose C is the body whose temperature is 30 degrees centigrade. Let us assume that suppose the body C has a temperature 30 degrees centigrade. Now if the body A also is having 30 degrees centigrade, that means that it is equal to its temperature is equal to the temperature of the body C. Fine. And if we get another body, another object whose temperature is also 30 degrees centigrade, that means the temperature of the body B is also equal to the temperature of the body C, then we can say that A is also in thermal equilibrium with the object B. Fine. So Zeroth Law states that if two systems are in thermal equilibrium with the third one, then the two systems which are in thermal equilibrium with the third one, they will be in equilibrium with each other, right? So what statement I have given? The Zeroth Law states that if two systems are each in thermal equilibrium with a third one, if two systems A and B are in thermal equilibrium with the third one, means with C, then they are in thermal equilibrium with each other. Then these two bodies will be in thermal equilibrium with each other, means their temperature will also be same. Okay. Let us take another example. Let us understand by taking another example. Suppose you and your friend, okay, suppose you and your class friend, you are having a common friend, right? You are having a common friend. So suppose Ram and Shyam, suppose Ram and Shyam, they are having, they know Sita, Ram knows Sita and Shyam also knows Sita, right? So what will happen if Ram knows Sita and Shyam knows Sita, means Sita became the common friend of Ram and Shyam. Now Ram and Shyam can also become the friend with each other, okay, when they meet with each other, right? So I have tried to make you understand this Zeroth Law with the example. Simply you can get this by going through the statement. Okay. Next law gives us the first law of thermodynamics. What does this first law of thermodynamics states? If we see around us, there are many energies around us, like the light energy, the heat energy, the chemical energy, okay, etc., etc. So what does this first law of thermodynamics states? First law of thermodynamics states that energy cannot be created, not destroyed. It can only be transferred, or it can only convert its form or transform into another energy, right. So what let us take an example. Suppose when you are lighting, you are giving your you are on giving the switch a on position. So what is happening? Your light is glowing. Okay. So what energy is converting into light energy? The electrical energy is getting converted into the light energy. Now when a bulb glows, there will be light energy and also heat energy, right. So the light energy also get converted into heat energy. So first law of thermodynamics states that the energy cannot be created nor be destroyed. Okay. It can only be converted into another form, right. So we can convert our suppose the hydel energy. If we take hydel energy means energy from the water. We are converting this energy into electrical energy. So the hydel energy is getting converted into electrical energy by the help of turbine, right. Now if you have seen the cycle with a dynamo fitted in it, and if you are going cycling the cycle, then the dynamo will give you the light also, means the mechanical energy is converted into the electrical energy, DC electrical energy. So the first law of thermodynamics I have written here. What I have written here, the first law states that energy is always conserved, means we cannot destroy energy, right. Energy, the whole energy is conserved, it is there in the nature or in your surrounding. So it cannot be created nor destroyed. We cannot manufacture it, or we cannot create it, or we cannot destroy it completely, or energy never dies out. It can only change its form, it can only convert it into another form. Suppose mechanical energy to electrical energy, then electrical energy to heat energy, then heat energy to light energy, or light energy to heat energy, in many forms. Another statement it also says that work and heat are mutually convertible. Work and heat are mutually convertible. Now heat is a energy, right. So if I am having energy, I can perform a work. If I am not having any energy, I cannot perform any work. So in why I have written this statement, the last statement, it also says that work and heat are mutually convertible. Mutually convertible means I can convert heat into work, or I can convert work into heat. Okay. So in our refrigeration system, our heat energy is the main factor which is giving us the work, right. So the heat energy is getting converted into work and keeps our food products cool, or keeps a space cool, right. Next, coming to the third point, there is the second law of thermodynamics. Now what is second law of thermodynamics? In second law of thermodynamics there are two statements, Kelvin-Planck statement and Clausius statement. Kelvin-Planck statement, what does it states? It states that there is no machine in this world which gives you 100% efficient work, right. There is no machine in this world, or no machine till now it is developed, or till now it is invented, that which will give you a 100% efficient work. So Kelvin-Planck statement states that it is impossible to construct 100% efficient engine working on a cycle. Okay. So 100%ly, so it is impossible to construct any machine which can give you a 100% efficient work working on a cycle or working on a principle, right. So working on a principle, suppose vapor compression cycle, if I take the refrigeration part, vapor compression cycle, the cycle on which based on which our AC or any refrigerator is working on, or any HVAC system is working on. So based on that cycle, if you want to construct a machine which will give you the 100% efficient work, that is impossible. Means if what you are giving the input, the output will be somehow, it will get reduced. Okay. So 100% efficient machines we cannot produce, or we cannot construct. So the Kelvin-Planck statement says this statement, right. So next statement comes as Clausius statement. Clausius statement, what does Clausius statement state? Clausius statement states that heat energy always flows from hot body to cold body, right. If you keep a hot body and if you keep a cold body in contact with each other, after some time you will see that the bodies of the two bodies are giving the same heat, right. So, what is happening, suppose this hand, my left hand is hot body, my right hand is cold body. If I am placing this hand in contact, my left hand, which is cold body, it will take the heat from the hot body, right. And how much it will take the heat? It will take the heat till the two bodies become equilibrium, thermally equilibrium, right. So, Clausius statement says that heat energy always flows from hot body to cold body without any external energy, right. If you do not have to put any energy for that flow to happen, the flow will happen automatically. The hot body will release its heat energy to the cold body, the flow will happen automatically. That why the name I given as thermodynamics, right. So, heat flows from hot body to cold body without any external help, but it cannot flow from a cold body to a hot body without the help of mechanical energy. But what does it, Clausius statement state that heat cannot flow from cold body to hot body. Cold body to hot body, heat cannot flow from this in this route, in this path, right. So, if you have to make this happen, if you have to make the cold body, make the heat to flow from cold body to hot body, you have to put some energy on that cold body to transfer the heat to the hot body, okay. So, in this principle, our refrigeration system is going on, where the work is done by the external work is done by the compressor, right. But if I have to make the heat flow from cold body to hot body, I have to give an extra energy, I have to provide an extra energy, external energy to the cold body for that flow to happen, okay. This was the Clausius statement. Last statement was that the third law of thermodynamics. What does the third law of thermodynamics states? See, everything, every matter which you are seeing around you or around us are made up of molecules, okay. We know that in solid the molecules are closely packed, the molecules are closely packed, in them the intermolecular forces are very strong and they are very closely packed. In liquid, the intermolecular force is somehow reduced and the molecules are somewhat they are in some distances, maintain some distances with each other. In gas, the molecules run randomly, right? Randomly, they run randomly, and they, suppose if I draw this picture of solid, in solid you will see that the molecules are closely packed here. In liquid, the molecules are spaced. In gas, the molecules are very much spaced apart, okay. So, third law states that if you take out heat from a body up to the absolute zero temperature, if you take out the heat from a body up to the absolute zero temperature, then there will be no movements of the molecules inside the body. The molecules will get freezed up and will become the statue and will become the static, and they will not move from their position, okay. In normal cases, what happens, the molecules generally in solid, they vibrate in their places. In liquid, they generally move, okay. In gases, they move randomly. Generally, this law is the third law of thermodynamics. I will read out the statement once. Third law states that entropy of a system at absolute zero is a well defined constant. Third law states that entropy of a system at absolute zero is a well defined constant. So, here you will see a term entropy. What is this entropy means? Entropy means the randomness of molecules. We know that in any matter the molecules never sit out static, they move, okay. So, in liquid they move maintaining some distances, in gas they move more maintaining more distances, but in solid they generally vibrate in their position. So, when the entropy, this movement of molecule is called the entropy. So, when the entropy of the system at absolute zero remains constant, or when they stop moving, is called the third law of thermodynamics, okay. So, here absolute zero, this term absolute zero means the temperature, the lowest temperature where there is no energy remained in a molecule. Okay. So, I will repeat this once again. Absolute zero means the lowest temperature where the energy of a molecule becomes 0. Okay. So, these are the laws of thermodynamics. So, I think you have I have understood the my video, and if you have any problem, you go through this video once again, and you can also talk with me in the comment sections. And if you like our videos, then share it and subscribe our channels. There are more videos coming, and that will get uploaded. So, thank you very much.